to the lecture. I'm going to talk about using non-generic collection classes from the system.collections namespace. And these have been around the .NET framework since version 1.1. This is a short little video. Microsoft recommends that you don't use these in new code, okay? Because the system.collections.generic namespace contains generic equivalents to a lot of these classes, and their performance of the generics is better, and I covered a lot of that in the previous video. But here I want to show you. One, because you might find yourself maintaining older code, and so it's nice to know how to cast, right, when you get the object out. The old school, what I call them, old school collections, are object in, object out. And essentially, they'll take any kind of object, but you have to remember what type of object got put in there, especially if you want to access one of the retrieve or access one of the objects in the collection and then call an interface other than what's provided by the system.object class. And that's why you got to cast it to the proper type. And generics does away with that, right? But we're talking about the non-generic collection classes here. So to help me out with this, I've got a class called person, which is given, well, let me start here. This lecture is based on material found in chapter 14 of my book, C# for Artists, 2nd edition. And it's the section using non-generic collection classes, which starts on page 409 in chapter 14. Example 14.5 gives the code for a person class. So let me go ahead and open up that class and just go over it real fast, show you what's in there. So I'm using Notepad++. I'm going to load it up in there. And I might as well load up the main app as well. Okay. I'll just put that right about there. So starting with person, I have a class person, public. It's got an enumeration called sex, which has two values, male and female. And then I've got some fields, private fields, underscore first name, middle name, last name, gender, and birthday. First name, last name, middle name are strings. The gender field is sex, which is this enumeration that I declared right there. And birthday is date time. And I've got two constructors. The first constructor just creates a person with sets everything to its empty or default value, all the fields. And then the second constructor, it's got parameters for each of the values you can set. And I follow that with all the properties. Okay. First name property, middle name property, last name property, gender property, birthday property. Those are all read-write. And then I have a couple calculated properties. One's age, okay, and calculates the age in years of the person. The next is full name property on line 81. And it just concatenates, it's a read-only. It concatenates first name plus the middle name and then the last name. And, puts a space in between each one of those. And then full name and age is the next property. And it simply just concatenates the full name property with the age property. Now, I've overridden the strings toString method, or the objects toString method, I should say. And it returns full name plus, and then the text is appended to, or concatenated to the gender type, right? Plus who is, and then age, years old. So if you had an object named Rick, right, or a person named Rick, it'd be Rick is a male who is I don't want to say years old. Okay, I'll say 29. All right, so that's the person class. Now the main app class, I'm using an array list, which is found in the system.collections namespace. So it's objects in, objects out, and then I create a bunch of person objects. And if you look at these names, except for the first one, that's me, They're artists from the Surrealist school. Max Ernst, Andre Breton, Roland Penrose, Lee Miller, and Henri Robert Marcel Duchamp, right? And so, and that's their birthdays. So once I created all these people objects, right, P1 through P6, I add them to the Surrealists collection. So surrealist.add P1, surrealist.add P2, et cetera, et cetera. And then here I can go through, right? I can say for each object O in Surrealists, console.writeline O.toString, okay? No casting, right? I put objects in, doesn't care that matter that it's a person object, but, you know, I'm just calling the toString method on it anyway. And the fact that I have actually overridden toString, I don't even need to put this, you know, call the toString method explicitly. So what happens here is console.writeline O.toString. This is calling the string version of the writeline method, right? I can totally take that .toString method call out of there and just put console.writeline O, and virtually, since I'm overriding that toString method, and I'll show you how that works here in a second. And then what I do is I go through the collection one more time. Down here on line 37, there's another for each statement, okay? Now, this is a implicit cast, okay? So the only thing I can really do, right, up here on the first for each statement is call, right, since I'm actually calling, you know, I'm going through the collection and I'm just getting each object. I don't care what type of object it is. I know it's an object. Everything's an object eventually. And then I'm just calling the methods that object class implements, right? toString, right? It implements a toString method. Except for now, the difference is down here on line 37, this for each statement, I'm casting. This is called an implicit cast because I'm going through the Surrealist collection, and even though it's objects in and objects out, this is going to cast, this person right here is going to cast this object that's retrieved, right? This reference is going to point to an object, but it's going to cast it to a person implicitly. And then I can do stuff like, you know, console.writeline p.firstname, right? And now the last for statement, let me choke up here so I can get a little bit more of a, okay, so on line, down here, line 43, this for loop down here, I'm saying for int I equals 0, I less than surrealist.count I++. So I'm explicitly going through the collection, right? I'm not using the iterator to go through, or the enumerator. I'm not using the enumerator to go through the collection, which is how the for each statement works. I'm just going through with a counter, right? So I go console.writeline, and then I say, you know, surrealist, right? Or surrealist I, so the ith element starts off at 0. I have to cast that. That's going to be an object, right? And then I cast that retrieved object to person, and then I put another set of parentheses around that, and I'm saying, hey, treat this object as a person dot first name plus person, right? I do the same thing and I get the last name. You know, I did that so I could show you how I could cast. Otherwise, I could call, you know, get full name, right? I could call I'd still have to cast the object to call any of the person methods, right? This is just one example of doing it. Okay, so let's run this code, and then I'll make a change to this for each statement so you can see I don't even need to do a toString call there. So I'm going to minimize this. I'm going to change directory, all right, to array list person, and we'll compile. Okay, now let's run it, main app. All right, so it says Rick Miller is 50 years old, right? Max Ernst is a male who is 124 years old, if they were still alive. Andre Breton is 119. Roland Penrose is 115, Lee Miller is 108, and Henri Robert Marcel Duchamp is 128 years old. Okay, and then here's where I'm going through with a for each, and I'm just getting the first name using the cast. And here's the last for loop, all right, the results of running the last for loop. Let me return to the code and just take out that explicit toString method call. So that's on the first for each statement on line 31. So I'm just going to remove this right here. Actually, what I'll do is I'll just copy this line. And I'm going to comment this out. And come back here and do this. Not that. I'm going to do this. Okay. And get rid of the toString call. There we go. And that should work the same. And the reason why is object provides a toString method. Well, when I override toString in a person, this works for any class. When I override toString, like this, override toString, then the virtual calling mechanism kicks in, and all I need to do, right, this WriteLine method is just says, give me an object. And WriteLine is overloaded. If you go explore the API documentation, the console.WriteLine method, there's a bunch of different versions, right, for integers, doubles, strings, objects. This is the object version. The previous one, like the one up here that I commented out, that's the string version. This is the object version. And that'll work. It'll work exactly the same. I just got to recompile. Let me do that. Oop, I didn't want to minimize. Okay, so clear the screen. Recompile. Okay, and then execute. And it works like a champ. Okay. Let's go back to the book here. So that's pretty much the code there. Now, assuming now you can create a strongly typed collection. Okay, with using an old school collection as a base class. So here I'm gonna on example in the next section, right, following that one. I have a section called Extending Array List to create a strongly typed collection. I'm going to create a person array list. I'm going to extend array list, and I'm going to call it person array list. I'm going to create a new instance of the indexer, okay? And then I'm going to override the add method. So let me just bring up the code for that. Let me close down this code here. And go to array list person. Extending array list. So I'm just going to, I think I can do it this way. I made a mistake and did this the other. Oh, wow. That's amazing. You see what I did there? I just copied the entire folder into Notepad++ and shebang, all the classes loaded up, all the files. So start with, we got the person, right? Obviously we got the person class, no change there. And then we got person array list, and which is given in the book. So what I did was I'm creating, I'm saying using collections. I'm going to extend, I'm going to create a new class called person array list. I'm going to extend array list. I'm going to create a new, that's what this new keyword here means. All right. I'm going to create a new version of the indexer. And essentially what this is going to do is it's going to, I can stick an object in, right? If I wanted to, right? Because I got setters and getter, I get getter and a setter. But mostly I'm just going to cast the when I pull it out of the array list, I'm going to cast it to person, so I don't have to mess around with that. And in this, since I don't cast when I insert, right? When I insert the person object, I'm not, impeded by, the checking of that. which may sound weird, but I'm the programmer. I know I'm going to put person objects into this array list. Now the override, the add method I'm overriding. And so, in this particular case, to override something, right, you have to keep with the original parameter. You can't make a change to that. But I can, in the internals, right, I can say if O is person, return base add O, right? And so it's going to return, I think it returns the position that it was. I think it might return success. I'm not really sure what it returns. Else, throw argument exception. So in other words, here I'm saying, well, if it's not a person, throw an exception, right? If it's not a person. So I'm doing a little bit of idiot checking on the add, okay? So the code will look a little bit different for the main app, all right? One, I get out of the business of having to cast when I step through my list, all right? So I'm coming down. I say person array list instead of just array list, right? Serial list equals new person array list. I create the same 6 people objects and I stick them in the collection just like I did before. Now here, right, I've got line 29 commented out and I say, if you try to add just any old object, right, with the add method, it'll throw an exception. And the reason is, right, because the way I implemented that, if it's not a person, it'll throw an exception. Okay, so I just put that line of code to remind people when they see this code. Now I can just go through with a for statement. I don't need to do an implicit cast with a for each. You could still, go through this with a for each statement. There's nothing saying you can't. But I'm just using a for statement. So for int I equals 0, I less than serialist.count I plus plus, console.writeLine serialist I dot full name and age. And that code is a whole lot cleaner, right, from a old school collection standpoint than having to cast, right? So you create a custom collection, a strongly typed collection, right? And you put the type checking in the guts of the new collection that you created, and it cleans up your code when you use it. So you're just kind of hiding the details of the implementation. Okay, let's return. Oh, we want to see it run. Of course, we do want to see it run. So let's go ahead and change directory. All right. So CLS CD. All right. Oh. CSC star.cs. Compile everything. Clear the screen. And run the main app. And that's it. Ba-boom. Everything runs great. Okay. Let's take a look at the book. All right, and that's it. Like I said, it was kind of a short lesson. The next lesson is going to be using generic collection classes. And that they've been available since .NET 2.0 and beyond. So I look forward to seeing you in the next lecture.